Hello there, Mr. Sutton here, bringing you the Algebra 2 9.3 lesson on collecting data. In this one, we will be identifying different sampling methods in statistical studies. We'll also analyze methods of collecting data, which is slightly different than sampling methods. And we will identify and reduce bias in sampling and survey questions. We're going to start this lesson with an overview of the statistical study process. It's good to see the big picture because we're going to be diving into each part of this in a little bit more depth over the next lesson or so. So the first step here, we always start with identifying some variable of interest and the population on which to study that variable. So for example, maybe we want to know what's the effect of a multivitamin on a certain age group. So we would, pick whether that multivitamin, gives that group more energy or better health. And the population, we'd have to pick probably a specific age group to study. So once you've identified these things, the next step is pick a representative sample of that population. It's going to be very tough to study the entire population, so usually you have to narrow it down and just pick a few. And there's lots of different ways to do that and ways that it could go right or wrong that we will go into in a little bit. After you've got your sample size, you're going to go and collect some data from that sample. After you've got your data, you're going to organize and describe that with a statistic, so maybe finding the mean, median, or mode, or any of a number of other things that you could do to organize that information. And once you've got everything organized or have a few of these statistics to work with, then at that point we interpret data, make some inferences, and draw conclusions about that population that we started with. So this is the whole process. In past lessons, we've already talked a little bit about populations versus samples, and also a little bit about hypotheses. All that's kind of step one stuff. So let's move on to step two and talk about some different methods of choosing members of your samples. And these methods are going to go in relatively decreasing order of accuracy, although there might be a little bit of wiggle room depending on how they're implemented. At the top of the list, and not really a true sample method, is a census. This is where you essentially choose your entire population. You don't pick just a piece of it, so it's not really a sample. But it is the most accurate way to figure out information about a population, is just to look at every single member. Unfortunately, it's not possible to do this most of the time because the population is usually just too big. I mean, even the US Census only happens once every 10 years because it's such a huge undertaking. And if we're being honest, not everybody actually answers the US Census, so even that is not a true census in terms of getting every single person in the country. But it's about the closest we come on that large of a scale. This is a little more practical on a smaller scale. Like if I ask my entire class, how the class feels about a certain policy or something else, smaller scale you can get everybody involved, but usually you have to settle for a sample. If you're settling for a sample, the most accurate sample is going to be a random sample, where every member of the population has an equal chance of being chosen. So you need some kind of device or way of implementing this. So kind of the common one for smaller samples is if you just have everyone put their names in a hat and you pick the names out of the hat. Or if you have a larger group, you could assign everybody a number on a list and use a random number generator to pick a certain group of them. Now, if you can't get a truly random sample like this, then you can come close with some of these other methods. So one of them is called the systematic method. This is where you choose using a certain rule. So maybe you look at a list of names and you choose every fourth name on the list, or every third name, or every other name, however many you want to choose. And this is usually going to come pretty close to random. The only place that this falls a little short is if there's already kind of a pattern to the list. I mean, let's say that I'm, trying to measure my weight and get a feel for what my weight is on a weekly basis. And I measure my weight every Saturday. I've got a system to it, right? Unfortunately, every Friday, maybe I have a big dinner at some restaurant, so maybe measuring every Saturday isn't going to give me a representation of the entire week. Anyway, this is usually a pretty good approach, but sometimes has flaws. Now, another approach that's up there is something called the stratified method. This is where you divide members into groups and then randomly pick from each group. So for example, let's say that I randomly choose students from each homeroom or each classroom or advisory. So this this splits it up so that we've got a bunch of different groups whose members have a chance of getting chosen, but within each group it's still pretty random. So one definite benefit of this method is that you can, consciously make sure that various groups that you care about are represented. So again, if we're choosing from each homeroom, this is going to guarantee that, the freshmen, sophomores, juniors, seniors, they all are more or less equally represented, even though we're randomly choosing from each group. So kind of a closely related approach that actually is quite different is something called the cluster approach. This is where you again divide members into groups, but instead of randomly picking somebody from each group, now you're going to randomly choose whole groups and just ask everyone within those randomly chosen groups. So each of the groups has an equal chance of being chosen, but then you just pick everyone in them. So for example, randomly choose some homerooms and ask all the students in these, completely leaving out the students in any of the other homerooms. So this method might be a little bit more convenient to implement than the stratified method because you don't have to go to a bunch of different homerooms, you just go to like a few of them. But it does definitely have some issues if the groups that you've broken your population into are too different from each other, so that you're completely underrepresenting certain members of the groups. So a couple other methods that are kind of at the bottom of the list, but they actually get used quite a bit. One of these is the convenience method, which is basically just surveying members who are easy to reach. So as an easy example, students in the cafeteria, right? You're having lunch and you stop eating and go around and start asking people questions just because they're there. So obviously this is very convenient, but it does have the issue where maybe students who don't eat school lunch, or maybe different age groups aren't in the same lunch as you. So you're definitely going to be leaving some people out depending on the time and the location that you pick for this. And the last one we'll talk about is the self-selected sample. This is where members volunteer to be in the sample or can volunteer. So a good example of this is when you have an optional online survey. For example, when the school district puts out a survey to all the students, parents, and teachers and just looks at the results of the people who answer it. Now, you might be wondering, well, all these different ways of surveying people, don't all of them kind of revert into a self-selected process? Because ultimately we can't force people in any of these systems to actually answer the survey questions that we're giving them. And in a sense, that is true. But we're just kind of assuming for convenience with all these other methods that people, for the most part, will willingly answer the questions that you give them. So I realized that was a long list of different surveying methods. We're going to get you a little practice with differentiating between them now. So let's say that you want to determine whether students in your school like the new design of the school's website. We've got 4 different samplings going on here. For each of them, pause the video and identify the type of the sample being described here. Give it a shot. All right, so let's go through each of them. For part A, you list all the students alphabetically and choose every 6th student. Since you're using a rule, this is a systematic sampling method. For part B, you mail questionnaires and use only the questionnaires that are returned. While the people who returned them basically are volunteering to answer the survey, so this is a self-selected survey. And then part C, you ask all the students in just your algebra class some question. This is going to be a convenience sample. You're just finding the people who are closest at hand and asking them something. Now, you might think because we're including a group in here, namely your algebra class, that this could be considered a cluster sample, but it isn't, because not all the classes had an equal chance of being chosen. It's not like you surveyed your algebra class and also surveyed a bunch of other classes that had an equal chance of being chosen. You just picked yours because it was the closest. And then the last one, part D, you randomly select 2 students from each homeroom. Well, since you're doing this, you're randomly selecting from some pre-chosen groups. Each homeroom counts as a group. This is an example of a stratified survey. If you were randomly selecting 2 students from the entire student body, then this would be considered a truly random survey. So while we were talking through all the different ways of sampling, we mentioned that some were kind of more accurate than others, and there was an implicit concept in what we were talking about there, and this is the idea of bias. Bias is an error in general that leads to misrepresentation of a population. When we're talking about sampling bias or sample bias, this is a sample method that over or under represents some of the members of our population. So when we're talking about accurate sampling methods, we're talking about accurately representing what the whole population would choose for its results with just a limited set of that population. And if you have a biased sample, then you're going to be skewed one direction or another with what your sample is telling you. So there are some common mistakes in terms of picking a sampling method that lead to this kind of bias. And we'll just go through a few of them, and then we'll see if you can pick some out in some examples. So one common thing that happens to give us some sample bias is when you have a self-selected sample. This tends to be biased toward members that have strong opinions about something. I mean, let's face it, filling out surveys takes time, so people don't tend to fill them out unless they either, for whatever reason, have a lot of time to kill and nothing better to do, or they feel really strongly about whatever the survey is about. So you're kind of missing a lot of those people who have only sort of mild opinions one way or another, but that's part of your population. So if you're not counting them really in your survey, you're not getting a true picture of how the general population feels about something. Now, another common one is when you do a convenience sample. This tends to be biased toward the members who are actually at the survey site. And I mean, not all of these survey sites are created equal. If you're just doing a survey on the street and just getting a bunch of random strangers, and there's a lot of different types of people who go through that particular place that you're surveying, you might be okay. But if you're taking a survey at a place where people go for a specific reason, like maybe you go to a karate dojo and ask people how they feel about teaching people self-defense. Well, you're going to get a different set of opinions than if you go to maybe an anti-war rally or something like that, right? So location can make a huge difference in terms of how the people in your survey are going to answer questions. And another one that we should mention, just kind of going from the bottom up on that list of sampling methods, was cluster method can sometimes be biased if your groups are too different from each other. For example, let's say you're trying to figure out how a school's sports budget should be spent, and in order to figure this out, you randomly select just a few of the sports teams, and ask them what they think. I mean, different sports teams are going to have different priorities in terms of what kind of facilities they want. So maybe that's not the best way to get a sense of how the general sports public feels about things. So with these in mind, here are a few questions for you to try out on this topic here. So I've given you 2 different situations. In one, we have a news channel asking viewers to participate in an online poll on bullying. In the other, a teacher who wants to know which extracurriculars the students at a school are most often joining asks students in her own AP computer science class about it. So for each of these, pause the video and identify the type of the sample, and then explain why the sample might be biased. All right, let's see what you came up with here. So for this first one, if we're having viewers participate in an online poll, that's something they have to volunteer for. So this is a self-selected sample. And the issue there, just kind of like we said up here, people with strong opinions one way or another on bullying are going to be overrepresented. And also, while we're talking about it, how about just the viewers of the news channel, right? Not everybody is viewing this news channel. Maybe not everybody even has a device to view it with. So this definitely skews results towards people who are viewers and do have such devices. So it might not represent the entire population's views on something. Now let's look at B here about the teacher in the AP Computer Science class. Since they're just asking the students in their own class, this is a convenience sample. And the issue here with asking about extracurricular activities is that the students in an AP Computer Science class have a pretty strong interest in STEM, science, technology, engineering, math, all that kind of stuff. So they might be a little bit more overrepresented than the general student population when it comes to picking clubs that kind of promote that interest, like a robotics club. So now that we've talked about how things can go a little bit wrong with sampling, let's give you a chance to design one that goes right. Let's say that you're a member of a school's yearbook committee and you want to pull members of the senior class to see what the theme of the yearbook should be. We've got 246 students in that class. Describe a method for selecting a random sample of 50 seniors to pull. Pause the video and give it a shot. All right, so there's lots of ways to do this. The key is that we have to make sure that each one of the 246 students has an equal chance of being chosen. So one way we could do this is assign each of those seniors a different number from 1 to 246, and then randomly draw 50 numbers, maybe using a random number generator, and then go ahead and ask those seniors. So at this point, we've gone on at length about step 2 of the statistical process, figuring out, sampling methods. So we're going to go on to step 3 now, data collection. And we're going to go through a few different methods for gathering data. So one of these is a very hands-on method called an experiment. This is where you literally do something to the members of a population and then measure the response and record that. So for example, giving willing patients, that's key here, giving willing patients a new medical treatment. Or if we're doing kind of a less life form based thing, maybe mixing some chemicals together and seeing what happens. In any case, this is an active process. Now, a less active way to do things is what we call an observational study. This is where you observe and measure variables without actually doing anything to the individuals or their environment. So for example, observing death rates in smokers versus non-smokers. I mean, we're not forcing people to smoke and then seeing whether or not that kills them sooner. We're just looking at people who smoke and don't smoke, seeing how long they live, and doing nothing actively ourselves in the process, but we are taking notes and seeing if there's a difference. So observational studies are a big go-to in situations like this and in other places where it would not be ethical to do something to the patients, even if they are willing. So definitely a big piece to have in your toolkit when you're collecting data. Now, another one that we sometimes use is the survey. This one's kind of straightforward. This is where you literally just ask questions of whatever your sample is. And the last one is a simulation. This is where you use a model to reproduce real-life situations. So one example of this may be using a computer model to predict the average rainfall for a month. Or kind of another example is if you're trying to test out the safety features in a car, you might put one of those mannequins, a crash test dummy, in the car and crash the car. Maybe just crash the car using a computer model, right? A simulated crashing of the car so you don't have to pay money for cleanup and all that. But computer models are really helpful when it's too dangerous to do something in real life, or like in the case of rolling a dice 50 times, 200 times over, when it would be really tedious to do it in real life and a computer can do it way faster. So with those different data collections in mind, pause the video and see for each of these 4 situations if you can identify the method of data collection described in the situation. Give it a shot. All right, let's see how we did. Looking at situation A, a researcher records whether people at a gas station use hand sanitizer. Okay, well, we're not forcing the people to use hand sanitizer, so it's not an experiment. There's no simulation involved here, and this could be a survey. You could be asking the people, but it doesn't mention whether we're actually asking them. So maybe we're just observing them, because people, if you ask them, they might not be honest about whether or not they sanitize. They might feel judged. So I'm thinking this is an observational study based on the way this is worded. This next one here, a landscaper fertilizes 20 lawns with a regular fertilizer and 20 lawns with a new organic one, and then compares the lawns after 10 weeks. Well, here we are actively doing something to the samples, so this is definitely an experiment. For part C, members of a student council at your school ask every 8th student who enters the cafeteria whether they like the snacks in the vending machines. We're asking people. This is definitely a survey. And then for this last one, a researcher uses a computer program to help determine how fast an influenza virus might spread within a city. Definitely a simulation since we're using a computer model here. It's not an experiment. We're not, introducing the virus into a city and seeing what happens. Not an observational study. We're not watching a virus spread, and we're not asking people about it. It's a simulation. For our last segment, we're going to revisit the concept of bias. We already talked about this in the context of choosing our sample, but we can also have bias in the collection of our data. And in this one, we're actually going to focus specifically on bias in picking our survey questions. So biased questions are questions that are worded in a way that's going to lead to inaccurate results. It's going to lead to people maybe not giving the answer that they truly believe in. So there's a few different types of questions that can lead to this sort of thing. One of those is in questions that encourage one answer over another. They're worded in such a way that somebody feels like they're expected to answer a certain way. Another thing that can happen is if we have questions that are too sensitive to answer honestly. A good example of this is if we ask people, about maybe how many hours they spend gaming, or, whether they do some kind of drug or something like that. I mean, there's some questions that have actual legal consequences if you answer a certain way and it's not a completely anonymous survey. So you might not get accurate information if you ask that kind of question. Another situation that happens is sometimes the question's unclear or doesn't provide enough information. If somebody doesn't actually understand the question or have enough information to answer it, why are you asking them in the first place? And then one other situation that we might run into is if a question addresses multiple issues. Just to kind of take a silly example of this, if you send out a survey question to students asking, for breakfast, would you like green eggs and ham? Well, there might be people who like the green eggs, there might be people who like the ham, but not the other, not both. So you're not really untangling those different pieces, you're making it kind of a package deal. So that might not give you all the information that you wanted out of that. So with these things in mind, here's kind of an example to see how all this plays out. So let's say that we're at the dentist, right? And the dentist is asking his patients, do you brush your teeth at least twice per day and floss every day? So pause the video, take a moment to think about this, and explain why the question may be biased or otherwise introduce bias into the survey, and then see if you can figure out a way to correct the flaw. And just as a little bit of a hint here, there may be more than one issue with this question. All right, let's see what we came up with here. So one issue with this is that the way the question is worded, there's a little bit of judgmental pressure in here to answer yes. I mean, saying, do you brush your teeth at least twice per day? That kind of implies that if you don't brush at least twice per day, then there's, something wrong with you. So people might not be answering honestly when you ask them that. So one way you might fix this is, there's a couple things you could do. One of them would be to ask how many times someone brushes. That doesn't, put as much of a judgment on brushing at least twice a day. Or you could just use a completely anonymous survey. People might be a little bit more honest if they don't have to look their dentist in the eye when they tell them that they never brush. There is another issue with this question as well. This question is actually asking about two different things, brushing and flossing. So two questions in one. I mean, this is an issue because someone might brush but not floss, or possibly vice versa. So an easy fix for this would simply be to just ask about brushing and flossing separately. This concludes our lesson on collecting data. Hopefully you found it informative and fun. I sure did, but I'm biased on that. Until next time, Mr. Sutton signing off.